Unit 8, Lesson 3, the properties of ionic, covalent, and metallic substances. So the properties of ionic compounds, you're going to notice these are very similar to the properties of metals. They are hard, they have a crystalline structure, they have high melting and boiling points, they are soluble in water, and they conduct electricity, but only if they're in a solution. Because keep in mind, to have electricity to be conductive, electrons must be free to move. So here's an example. We have water. It does not conduct electricity because it is a covalent compound. We have salt. The problem with salt is the ions are packed tightly, so the electrons are not free to move. But once you add salt into water, that allows the ions to move freely throughout the water, and then it will be able to conduct an electrical current. So properties of covalent molecules, well, they're soft. They have low melting and boiling points, and this is due to the weak attraction between the molecules. They do not conduct electricity due to their lack of charged particles. Metals do have high melting and boiling points because their bonds are very strong. This is the reason why we make buildings out of metals and not out of covalently bonded compounds. They will conduct electricity because the electrons are free to move. So here we've got our electrons moving freely, and this is where they get the term sea of electrons, or the sea of mobile electrons, because the electrons will just move all around, and if we would happen to introduce a charge like or static electricity of some sort, you would notice that the electrons would all be attracted to one side. If this was a positive up here, the electrons would all kind of hang out in this area because there is an attraction. So let's practice. A solid substance is an excellent conductor of electricity. The chemical bonds in this substance are most likely which? So we can rule out a few because we know that metallic compounds are conductive of electricity, but one of the key terms that we read through here is, here it says ionic because the valence electrons are shared. Well, that's not right because they're not shared at all. They're just attracted to each other, so we can cross A off. Ionic because the valence electrons are mobile. That just seems a little oddly worded, but we'll kind of keep that in mind for a moment. Metallic because the valence electrons are stationary. Well, if it's a stationary electron, then electrical currents cannot possibly occur, and so that leaves D, metallic, because the valence electrons are mobile. So technically, if we're looking at chemical bonds, the most likely, the most correct answer would be D. However, ionic can have mobile electrons, but remember, only if they are dissolved in some sort of liquid. So they would actually have to be dissolved for B to be true. So here the answer would be D. So a substance is an excellent conductor of electricity in solution. The chemical bonds in this substance are most likely, well, we can rule out C because covalent is not at all a good conductor. And that then leaves A because it's ionic and its valence electrons are mobile. Ionic because the valence electrons are stationary. Well, we can rule this out because to be stationary, you would not have an electrical current. And so that leaves A and D. And D, metallic, because the valence electrons are stationary. Stationary, that crosses this one off. So the answer would be A, ionic, because the valence electrons are mobile. Now keep in mind, since this is in a solution, this would be the correct answer, A.